So trigonometry with right-angled triangles. Trigonometry comes from the Greek word trigonon, which means triangle, and metron, which means measurement, because we're measuring things in our triangles. Okay? Trigonometry deals with the relationship between the sides and the angles, whereas we had Pythagoras' theorem, which would only deal with the sides, didn't it? So year 9 revision. We have our right-angled triangle there. You need to remember how to label your triangle. If theta is here, then the side directly across from it is the opposite. The one across from the right angle is the hypotenuse. And the side joining your theta and your right angle is your adjacent. And you know that you get these rules from that. So you get SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent.
This one's Q.
When I put this into OneNote, it changed the theta into a Q. It's on your booklet, correct? It says theta on your booklet. Okay, so I did it in here as well. So they've just replaced it with a Q. I don't know why it always does that. It's very annoying. Okay. Yeah, that one worked and that one in there didn't. Okay, so this is the new stuff. Did you know there is actually 3 more trig functions that you need to learn about? And that is, the proper name is cosecant, but we shorten that to cosec. And secant, which we shorten to sec, and cotangent, which is cot. So you're not really going to remember the full name, you're going to remember these one, cosec, sec, and cot. Now, the good news is that they're not completely new. They are just reciprocals of the functions that we already know. So cosec is just 1 over sine theta. Yours says theta, not q. Okay? If sine is opposite over hypotenuse, that means that cosec is going to be hypotenuse over opposite. It flips that fraction upside down because the reciprocal turns the fraction upside down, doesn't it? Yes? Why is everyone looking so stunned? Yes, that makes sense? Okay, good. So sec is 1 over the cos function. Okay, so sec is 1 over cos. Cos is adjacent over hypotenuse in the SOHCAHTOA. So that means you just got to turn that upside down. It's going to be hypotenuse over adjacent. And finally, cotangent or cot is 1 over tan. Okay, tan is opposite over adjacent, so cot is going to be adjacent over opposite. Now, here is a nifty little trick. I'm going to unhighlight these. To remember which one they're over, you always look at the third letter. So, cosec, the third letter is a sine, so it's over sine. Sec, the third letter is a C, so it's over cos. And cot, the third letter is a T, so it's over tan. 1 over tan. There you go. You will never forget those ever again.
Hey, miss.
Right?
Why is it 1 over the sine or hypotenuse opposite? Why are they the same?
Because by doing 1 over something means that you're taking a reciprocal. Okay? And cos is adjacent over hypotenuse. So the reciprocal is going to be the hypotenuse over the adjacent. It's turning our normal cos rule in SOHCAHTOA upside down. Okay? All right. Next thing. No, you don't have a cosec second cot button on your calculator. No, you don't. You only have sine, cos, and tan. All right, next thing. This one is not completely new. You have seen these last year. You must be able to find the exact ratio of sine, cosine, and tan for 30, 45 degrees, and 60 degrees. And the easiest method, it's not the only method, but the easiest method is to know those triangles that are there. Are they on the formula sheet? Yes, they are. Yep, they are on your formula. Yes. So remember how to use them. We're going to fill in this table here. If I want to find sine of 30, there's my 30 degrees, and we're going to be using SOHCAHTOA. So I'll write that on the side here. SOHCAHTOA. That's really messy. I need to move my computer. Let's try that again. SOHCAHTOA. Okay, so sine is opposite over hypotenuse. So from the 30 degrees, the opposite is 1 and the hypotenuse is 2. So that's going to be equal to 1 over 2 or a half. Let's keep going with the 30 degrees. Cos is adjacent over hypotenuse. So the adjacent is root 3 and the hypotenuse is 2. You reading them off the triangle. Tan is opposite over adjacent. So the opposite is 1 and the adjacent is root 3. We're not going to worry about rationalizing the denominator. Cosec, the third letter is S for sine. So that is going to be the reciprocal of sine. If sine was 1 over 2, then cosec is going to be 2 over 1. I'll write that down first, or just 2. Sec is 1 over cos, the third letter C. So if cos was root 3 over 2, it's going to be 2 over root 3. And cot, third letter is T for tan. We need to turn 1 over root 3 upside down to be root 3 over 1, or just root 3. Seems easy enough? Let's do it all again for sine 60 degrees now. So here's my 60 degree angle. What is sine of 60? Who wants to do it? Sorry, what was that, Jess? Oh, yep. Excellent. Root 3 over 2. All right, cos 60. Cos is adjacent over hypotenuse, which is? Excellent. Tan 60 is opposite over adjacent. Opposite is? So just root 3 will do. And then the inverse functions, or the reciprocal functions. So cosec.
Do the last two letters really need to be there in cosec?
Yes.
Otherwise, it's just cos.
Yes.
Oh, good point.
Good pickup. Sorry, sec was? What's sec going to be?
2 over 1.
Sorry, yep, Jess, good. 2 over 1 or just 2. And cot is the T.
Oh, I just wrote that.
All right, so I can hear that Jess knows how to do it. How about everybody else?
Yeah.
Yeah?
It's 1 over
Yes?
root 2.
1 over root 3.
Oh, for the next one. You already started.
Yeah.
Okay, let's go. 45 degrees using the second triangle. So sine is opposite over hypotenuse, which is 1 over root 2. Cos is also 1 over root 2. Tan is opposite over adjacent, which is 1 over 1, just 1. And cosec, third letter is S for sine, so root 2, excellent. Sec,
So you're amazing.
apparently cross country meant a lot of people didn't come today.
Yeah, there's like no one here.
They're
Yeah.
gonna miss some balls.
They are.
Can you sing the Max is Fun song? Can I sing it?
Yeah.
Oh,
You are
just
being
have to wait for
recorded.
the movie to come out.
Yeah. Anyway, keep going. Third letter for sec is C
Root 2.
and cot.
It's 1.
Oh, too easy. All right, next page. Next page. Example 1.
Oh gosh, I let my
Guys.
page.
Don't be silly. Talking to Isaac. Find the exact value of sine alpha, cos alpha, tan alpha, sec alpha, cosec alpha, and cot alpha. All of them, basically. So we're not actually finding the alpha, we're just writing down the fraction that we get from our opposite over hypotenuse.
So exact value means the fraction?
Yes. So sine alpha using that triangle, my opposite is 5, my hypotenuse is 13, so 5 over 13. Cos alpha, cos is adjacent over hypotenuse, so that will be 12 over 13. Tan alpha, it's like a fish.
A but a D.
A fish.
A but a D.
Tan is opposite over adjacent, so that's going to be 5 over 12. Now I'm going to do all my cosec, sec, and cot just to the right of that. Cosec, alpha, sec, alpha, and cot, alpha. and they are just the reciprocals of all the ones that I just found. So cosec is reciprocal of sine, so that'll be 13 over 5. Sec is reciprocal of cos, so 13 over 12. Cot is the reciprocal of tan, so 12 over 5. And that's it, that's all you have to do. Question 2, this is just good old-fashioned SOHCAHTOA, finding sides and angles in your triangles. So I'm going to write SOHCAHTOA up the top here as a reminder. So looking at question 2, the 38 is going to be the theta, that's the angle. The x is my adjacent side, and the 22.5 is the hypotenuse. So adjacent and hypotenuse means that I need to use Cos formula. So that's cos theta equals adjacent over hypotenuse. When I sub into that, I'll get cos 38 equals, my adjacent is x, and my hypotenuse is 22.5. Now remember that sometimes the x is on the top and sometimes it's on the bottom. When it's on the top, that's the easier one, where you just have to times the 22.5 across. So that will be x equals 22.5 times by cos 38. Has anyone typed that in already?
17.7.
Excellent. 17.7. I don't have any units, as in centimetres, to add to that, so I just have to leave it like that. Let's try B. My theta is the 38 degrees 11 minutes. The 7 is the opposite, and the x is the adjacent. So that means I need to use tan. Opposite and adjacent is tan. So write the formula down. Tan theta equals opposite over adjacent. Subbing in, my theta is 38 degrees 11 minutes. Opposite is 7, and the x is on the bottom. When the x is on the bottom, what happens? You switch, that's right. The x switches places with the tan 38 degrees 11 minutes. Now what you're really doing is you're timesing the x up to the other side, and then you're dividing the tan back the other way, but we just do that as a shortcut. So x equals 7 over tan 38 degrees 11 minutes. You're all okay using your degrees and minutes button? No? I'm going to type that in. So we go fraction 7 over 10. You press 38 and your bubble button. Remember the bubble button? Yeah. So this one here. And then you have to press 11 and press that bubble button again. You'll need to close the bracket. Okay, press equals 8.9. And part C, we're finding the angle. So the 4.12 is the opposite. The 5.35 is the hypotenuse. So opposite and hypotenuse is going to be the sine rule. Sine theta equals O over H. Subbing in, trying to find the theta, so that's still going to be in there. The opposite is 4.12 and the hypotenuse is 5.35. Now, haven't done one of these yet. How do I get the theta by itself?
Inverse sine.
Yes, we call it inverse sine. So in here we go shift sine to bring up that sign with a little -1. Then we need our fraction button, 4.12 over 5.35. Close bracket equals. Now this is an angle, so let's practice doing degrees and minutes. So press that bubble button, and that's 50 degrees, 21 minutes and 44.22 seconds. We usually round to degrees and minutes in this kind of case. So because the 44 is above 30, it works like time. These work in lots of 60, so 30 is halfway. Anything above 30 rounds up, so that's going to be 50 degrees and 22 minutes rounded up.
Wait, can you go below seconds?
Yeah, you could, but our calculator doesn't.
Oh.
So All right, that
Yeah,
is
like
it.
microsecond, nanosecond.